Welcome back, everyone. Hope everyone's having a good day. We're on our final day now of practice test number 7. Remember, we're taking 4 days for each one, 2 for each module, and we're doing only the math section. Today, we're finishing off module 2 here, and we're going to start with this problem over here. Question number 18. The solution to the given system of equations is x, comma, y. What is the value of 39x? Okay, so we have these equations. We're going to simplify by adding them. -6. So this gives us x is equal to 6 over 13. And it's asking what the value of 39x is. So 39x is equal to 39 times 6 over 13, which is going to be equal to 18. And that's answer choice D. Okay, now problem number 19. Function h estimates an object's height in feet above the ground t seconds after the object is dropped, where b is a constant. The function estimates that the object is 3,364 feet above the ground when it is dropped at time t equals 0. Approximately how many seconds after being dropped does the function estimate the object will hit the ground? Okay, so we need to know when the object will hit the ground. We know it starts at 3,364. So 3,364 is equal to negative 16, 0 squared plus b, since this is when time t equals 0. So we know b is equal to 3,364. Plugging this into our equation, we get h of t is equal to negative 16t squared plus 3,364. Now, what we have to solve for is when the object hits the ground. So that's when h of t is going to be equal to 0. And then we solve now for t. 16t squared is equal to 3,364. T squared is equal to 3,364 over 16. And then t is equal to the square root of 3,364 over 16. And it's not plus or minus this time because it's time. Time can only be positive. So we have 3,364 divided by 16, we take the square root of that, and we get 14.5. One solution, all right, question 20 now. One solution to the given equation can be written as 8 minus square root of k over 4, where k is a constant. What is the value of k? For this looks like a solution from a quadratic equation. So we have negative b plus or minus square root of b squared minus 4ac over 2a for our quadratic equation. And using our points here, we know that a is equal to 2, b is equal to negative 8, and c is equal to negative 7. So we have 8 plus or minus the square root of 64 minus 4 times 2 times negative 7 over 2 times 2. And this is going to give you 8 plus or minus the square root 64 minus negative 28, 54, 56 over 4. And this is going to be 8 plus or minus the square root of 120 over 4. So k in this case is going to be 120. Okay, question 21. A line intersects two parallel lines, forming 4 acute angles and 4 obtuse angles. The measure of one of the acute angles is 9x minus 560 degrees. The sum of the measure of one of the acute angles and 3 of the obtuse angles is negative 18x plus w. What is the value of w? Okay, so if we know one acute angle is that, and 3 obtuse and 1 acute is this, we have to set up a little drawing first to visualize this. Doing the drawing here, there's not much space on that side. So this is the visualization. On each side, we have 2 acute and 2 obtuse. So we know that 3 of these obtuse angles and 1 acute angle will equal this. So the way I'm thinking of this is that we can multiply this value by 3. So because we need an even number of both amount of angles. This is the easiest way to approach it. What we want to do is cancel out negative 18x and 9x. So to do that, we could multiply 2 by the whole thing over here, and then keep this the same here. And we have to keep track of the amount of angles we're using. So if we have 2 acute angles, and then this would be 1 acute angle and 3 obtuse angles, we would have 3 and 3 angles, 3 acute and 3 obtuse angles. We don't know what that angle will be because we don't know what the obtuse angles are, or the acute angles are. So what we need to do is have an even amount of both. And the way to do that is by multiplying this value by 2. So we get 6 obtuse angles and 2 acute angles, and then you multiply this by 4. So you get 4 acute angles. So we have the same amount of both angles now. And this means that if we have 3 acute or 6 acute angles and 6 obtuse angles, so 6 of each, and we know that 2 of each make 360 degrees, we're going to have 360 degrees 3 times, which is equal to 1080 degrees. So given this, we can simplify this over here and then set it to this value. So we have 36x minus 36x, and then 4 times negative 560, which is negative 2,240, and then plus 2w. So these cancel out, and then remember this whole thing equals 1080 degrees. So we have 2w is equal to 3,320. Then we divide that by 2, and w is equal to 1,660. The hardest part of this problem is figuring out how to multiply these variables to get them to cancel out while also making sense in terms of the degrees you're setting it equal to. So once you figure that out, it's really simple. I just thought of it as making 3 circles with the angles we were given, because we know the degrees within a circle, but we don't know the degrees of part of a circle without the angles. So w is 1,660 for that problem. Okay, question 22. For the linear function f, the table shows 3 values of x and their corresponding values for f of x. If h of x is equal to f of x minus 13, which equation defines h? So we're going to solve for f of x first. So f of x is equal to mx plus b. Let's solve for m. We're going to choose, this is y2, this is y1, this is x1, this is x2. So we get 1 minus 0 over negative 19 over 5 minus negative 4, which is just plus 4. So this is going to be 1 over negative 19 over 5 plus 20 over 5. 20 over 5 is equal to 4. So this is going to be equal to 1 over 1/5, which is equal to 5. So we have f of x is equal to 5x plus b. Now we're going to solve for b by plugging in this point over here, negative 4, 0. So we have 0 is equal to 5 times negative 4 plus b. b is equal to 20. So that means f of x is equal to 5x plus 20. Now h of x is equal to f of x, which is 5x plus 20, minus 13. So that gives us 5x plus 7. Looking at our answer choices, this is choice B, and that's it. Question 23, the linear function g is defined by g of x is equal to b minus 15x, where b is a constant if g of c plus 7 is equal to c over 4, where c is a constant. Which of the following expressions represents the value of b? Okay, so the value of b we need to solve for, so we know g of c plus 7 is equal to, now we're going to plug it into this, b minus 15 of c plus, or 15 times c plus 7. And we know this value right here is equal to c over 4. Then we're going to distribute this. 15 times 7. So we have b is equal to c over 4 plus 15c plus 105. So b is equal to, we'll keep it on the same side for simplicity, c over 4 plus 60c over 4 plus 105. We're just simplifying this because the answer choices have everything over 4. So we have b is equal to 61c over 4 plus 105. This is answer choice C. And yeah. Okay, next problem. In triangle XYZ, angle Z is a right angle and the length of YZ is 24 units. So let's draw that out. Sorry, I'm going to draw it differently so it makes more sense. So X, Y, Z, Z is a right angle, and the length of YZ is 24 units. Tan of X, so this angle right here, the tangent of X, is 12 over 35. What is the perimeter in units of triangle XYZ? So we're looking for the perimeter. We only have one side as of now, but it gives us the tangent of X. We know the tangent of X is equal to the opposite over the adjacent side. So 12 over 35. And if we multiply both of these by 2, we're going to get 24 over 70. And I'm doing that so it matches with this side over here, because this is our opposite side and this is our adjacent side. So now that makes sense because our adjacent side can be equal to 70. And now we can use Pythagorean's theorem to solve for the last side. So a squared plus b squared plus c squared. So ignore the adjacent and opposite. We're going to say this is equal to a and that's equal to b. So we have c is equal to the square root of 24 squared plus 70 squared. So 24 times 24 plus 70, and then take the square root, and you get 74. So that's your hypotenuse. And now we need to sum up these three angles, 74 plus 70 plus 24. So with that, you get 168, and that's answer choice B. Okay, question 25. In the xy plane, the graph of the given equation is a circle. What is the length of the circle's radius? So for this, you need to know how to complete the square. Remember, completing the square, you need to know how to take b over 2 and square it, and then add them to each side for each variable of x and y. So we have x squared plus 14x plus y squared minus 6y is equal to 109. Remember, move all your terms to one side. So we have x squared plus 14x plus 14 over 2 squared plus y. I'm going to put this in parentheses, and then we'll put this in parentheses too, so it separates our y and x variables. So y squared minus 6y plus negative 6 over 2 squared. And all of this is going to be equal to 109 plus 14 over 2 squared plus negative 6 over 2 squared. So with that, we have x squared plus 14x plus 49. 14 over 2 is 7. 7 squared is 49. Plus y squared minus 6y plus 3 over 2 is 3, or negative 3, and squared is 9. And then this is equal to 109 plus 49 plus 9. So it's just asking for the radius, so we don't have to worry about this side particularly. It's only this that matters. So we have 109 plus 49 is 100. 158, and then plus 9 is 167. So this is equal to r squared, because remember, the radius is going to be 167, or the square root of 167, because this value right here represents r squared, based on the standard formula for a circle. So C will be your answer for that problem. Question 26, the speed of the vehicle is increasing at a rate of 7.3 meters per second squared. What is this rate in miles per minute squared, rounded to the nearest tenth? Okay, so we have our conversion factor here, 7.3 meters every second squared. So we have 1 second squared. And then this is stoichiometry. If you've ever taken chemistry, this will help a lot. You got to cancel out these variables. So we're going to get rid of meters and convert it to miles first. So we know that there's 1,609 meters in every mile. So we canceled that out. So we have our miles. We want miles per minute squared. So now we need minutes squared. And to do this, we have to convert the second squared. But you can't just square only a unit. It has to be its whole value and the unit. So that's why we're putting the squared on the outside here. So every 1 minute we get 60 seconds. And once we square this, you'll see we'll have 1 minute squared over 3,600 seconds squared, and the variables will cancel out perfectly. So now we're left with miles over minutes squared, which works. And now we just plug this into our calculator. It's going to be 7.3 times 60 squared divided by 1,609. And this is going to give you 16.33. It's asking to round to the nearest tenth, so 16.3. B is your answer. Okay, last problem for the whole test. Made it this far. This is a pretty difficult problem to finish it off, but you can do it. In the given system of equations, k is a positive integer constant. Positive integer constant. The system has no real solutions. So these lines cannot intersect. What is the least possible value of k? So this is a discriminant question. I talked about the discriminant in earlier videos. So for this, if there's no real solution, b squared minus 4ac is less than 0. However, we need to set up and combine our equation before we plug it into this discriminant formula. So we know that y is negative 2.5. So we could plug that in for this value right here. Because when we set them equal to each other, we know that there's no real solution. And that's why we use this formula. So we have 0 is equal to x squared plus 8x plus k plus 2.5. I put these terms in parentheses because they are both constants. And this will be our c term, this will be our b term, and then 1 will be our a term. So now we could plug it into this formula of b squared minus 4ac is less than 0, so we know that 8 squared minus 4 times 1 times k plus 2.5 is less than 0. 64 minus 4k minus 10 is less than 0. 54 is less than, we can move this 4k over, 4k, and then k is greater than 54 divided by 4, k is greater than 13.5. This isn't our answer though. Remember what I said at the beginning. The system has no real solutions. K is a positive integer constant. Integer means it can't be a fraction or a decimal, so k must be greater than 14. Can't be greater than 13 because that's below 13 and a half. So 14 is your answer. Just write that out for you. We're going to stop the episode here. I hope practice test number 7 helped you guys. Always practice on your own with other practice tests. I really suggest the adaptive ones online on Bluebook because it really shows you an accurate score of where you're at. And yeah, really just do all of them you can. I'm going to do another one of these with practice tests 8, 9, and 10. So if you feel like you need another run through of a practice test with help, I really advise watching those videos that are going to come up. And yeah, good luck on your study.